At the end of class today, we started looking at exterior angles and calculating the actual value of the exterior angle. After having done that, we went back and found the sum of all of the exterior angles in each of these diagrams. So in this first diagram, when we added together our three exterior angles, the 81, the 132, and the 147, we found that the sum of these three angles came out to equal 360 degrees. Then we did the same thing on the next one, adding together the 41, the 111, 43, 55, and 110, and found that once again, the sum added up to 360 degrees. And then finally, when we did it at the last one, 63, 75, 57, 70, 25, and 70, we found for a third time that the total was 360 degrees. So as a conclusion, we could say that regardless of the type of polygon and regardless of the number of sides or angles, the sum of the exterior angles will always add up to 360 degrees. This leads us to the polygon exterior angle sum theorem, which says that if we are finding the sum of the exterior angle measures of any convex polygon with n sides, that total will always be 360 degrees. Now, when we apply this, it says find the sum of the exterior angles of a convex 20gon. Well, again, regardless of the number of sides, as long as we are talking about the exterior angles and the sum, we know that the sum of the exterior angles will always be 360. Then it says find the measure of each exterior angle of a 20gon if it is regular. So once again, we're finding each angle. That means we're finding each individual one. We do know that it's a regular polygon, meaning that all of the angles are the same. And if it's a 20gon, then that means there are also going to be 20 angles. So to find the measure of one of those exterior angles, we're going to take, we're going to take our sum of 360 degrees, divide it by the 20 angles that are all equal to each other, and 360 divided by 20 is 18 degrees. Therefore, each exterior angle is 18 degrees. Now, when finding in our last question here, now we're going to go back and find the measure of each interior angle in a 20gon. There are actually two methods we could use to find this one. Method one would be going back to what we did previously in our lesson, which was that we should find the total degrees in the total degrees in the polygon, and we can find that by doing n minus 2 times 180. And then we're going to divide by the number of angles because, again, if it's regular, all angles are the same. So we're going to actually divide by n, the number of sides or the number of angles. So using this method, if I plug in my 20 sides, 20 minus 2 times 180, and then we're going to divide by our 20 angles, that's going to be 18 times 180, which is 3,240, and if we divide that by 20, we're going to get 162 degrees for each of the interior angles. Now, another follow-up method to finding that interior angles would be to remember that regardless of the number of sides, if we draw this polygon, and I'll just draw part of it. So let's just say I drew this part of the polygon. And an exterior angle is formed when you take one side and extend it past the other side. So we had previously found out that my exterior angle was 18 degrees. I can throw that 18 right here. And if I wanted to know the interior angle, keep in mind that the exterior and the interior angles are a linear pair and will add up to 180. So another alternative method would be to take 180, subtract that exterior angle, and that 162 degrees is going to have to be my interior angle. So again, the first method really goes back to finding the total degrees in the polygon and then dividing by the number of angles if it's regular. Our second method really starts with finding the one exterior angle and using that exterior angle to find the interior angle. And again, this works as long as the polygon is regular. So if we look at just a couple more examples of working with these exterior angles here, if we know we want to find this time the number of sides of a regular polygon whose exterior angle measures, exterior angles each measure 4 degrees. Once again, there's two ways that we could solve this one. Method one would be strictly using the exterior angle. If we take the exterior angle, the value of one exterior angle, and we multiply it by the number of angles, that should give me my total. Well, we know that the exterior angle is 4 degrees. We don't know the number of angles, but we're solving for that, so I'm going to call that x. And we know that the total of the exterior angles needs to be 360 degrees. So if I solve this equation by dividing both sides by 4, the number of angles will be 360 divided by 4, the number of sides, which would have to be x equals 90. So this would have to be a 90-sided polygon. Method 2 would go back to what we did in class today, where we could say that if one exterior angle is 4 degrees, then one interior angle would be 176 degrees, since remember, these angles form a linear pair, and therefore they add up to 180. So then I could take that interior angle and say, well, one angle is 176 degrees. I'm going to multiply that by n, which is going to be the number of angles, and that should equal the total. But in our case, the total for the interior angles is n minus 2 times 180. So now this is obviously a longer equation. If we take 176n, distribute that 180, so we'll have 180n minus 360. If I subtract the 180n from both sides, so minus 180n on both sides, that gives us negative 4n equals negative 360, and once again, n is 90. So in either case, whichever method we're using to solve this, we do end up with a 90-sided polygon. Okay, as a quick follow-up example, just to kind of see one more, remember we do have two different methods that we could solve this. This time, however, they're giving us the interior angle. So option 1 would be to say if the interior angle is 135 degrees, then the exterior angle will have to equal 45 degrees. Once again, these are a linear pair. Then I can take my exterior angle and say, let's take that one angle, multiply by the number of angles or the number of sides, and for exterior angles, that has to equal 360 degrees. So 360 divided by 45 means that this is an 8-sided polygon. There are 8 angles, 8 sides. We would call this an octagon. The second method was what we learned originally, which again said that if the interior angle is 135 degrees, then I can take that one interior angle, multiply by the number of angles, and set that equal to the total, which for interior angles, remember the total is n minus 2 times 180. And then just like we did before, we're solving this equation, 135n. I'm going to distribute, so that's 180n minus 360. I'm going to subtract 180n from both sides. 135 minus 180 is, once again, 45. So negative 45n equals negative 360. And when we divide, we get n to be 8 again. Our final example deals with, an irregular polygon. So once again, you'll notice that we have all of these exterior angles that are labeled. We're going to take each of these exterior angles and add them together. So 33b plus 16b plus 10b plus 28b plus 15b plus 18b, running out of room here, and I'm going to set it equal to the total. Now remember though, with exterior angles, your total is going to be a very simple 360 degrees. So in this case, I'm going to be adding all of these together and setting it equal to 360. When I add all those like terms together, I get 120b. When I divide by 120, then b is 3 degrees. So your assignment on this asynchronous day is to try the day 1 and day 2 homework that was on the daily calendar from yesterday. And we're going to be going over that assignment and doing some additional practice with it tomorrow in class.